All right, welcome to another episode of Physics with Mr. Peacock. We are here on page 6 of our Unit 4 notes on net force. We're talking about adding vectors. So when we have forces or vectors that are going in two different dimensions, some in x and some in y, we're going to add them together using a method called tip to tail. So what we're going to do is put the tip of one vector up to the tail of the next vector. And they're going to make a shape. If the forces are balanced, then we should start and end at the same point and we'll make a closed shape. If the start and the end point are not the same, we know that the forces are unbalanced, and we're going to have to close the shape by drawing in the net force, which we're going to draw as a big arrow. So we'll start by looking at this example. Here I have four vectors, k, m, l, and n. And I'm going to go ahead and make my start point, probably this point here. And I'm going to choose the vectors one at a time, and I'm going to draw them in, but I'm going to redraw them tip to tail. So I'm going to start with k. I see that k goes 1, 2, 3 squares in the y direction and does not go in the x direction. So I'm going to go 1, 2, 3 squares in the y direction. And I'm going to draw in my arrow k. So k, check. The next thing I'm going to do is draw in, we'll go with n. So I see that n goes 0 squares in the y direction. It does not go in the y direction, but it goes 1, 2 in the x direction. So I'm going to start n tip to tail at the end of k. And I'm going to go 1, 2. And we can see that the back of n, or the tail of n, starts at the tip of k. So I've just placed them tip to tail. Next, I'm going to look at, so we'll take that one. Next, we'll do m. I see that m has an x component and a y component. It goes 1, 2 in the x direction and 1, 2 in the y direction. So I'm going to come over here, and I left off here at the top of n, and I'm going to go 1, 2 in the x direction, 1, 2 in the y direction, and draw in my force m. And the last one I have is L. So I see that L goes 1, 2 in the x direction to the left, and then 1, 2, 3 down in the y direction. So I'm going to go 1, 2 in the x direction, 1, 2, 3 in the y direction. And I'm going to go tip to tail, and I'm going to add that one in, L. Now I've added all four of my vectors, and I see that it's not a closed shape. I did not start and end at the same point. I started here, and I've ended here. So I look back at my notes, and I see when I've start and end at different points, my forces are unbalanced, and I need to draw in the net force. So the net force starts where we start and go to where we finish, and we draw it in as a big arrow. Just like this. And the reason we draw it in as a big arrow is so it's easy to tell which one is the net force. And we can even label it F net. And now I want to break down my net force into its x and y components. So I see F net x. I see that it goes 1, 2 in the x direction. So that's 2 squares. And my F net y goes 1, 2 in the y direction. So that's -2 because it's going down. So I've added all of these forces together. I see that they are not balanced, so I draw in a net force. And then I determine what is the x component and what is the y component of that net force. Now, a quick refresher for anyone who needs to just have a little extra practice on components is, say I have this force here drawn in as F, and I know that that is 50 newtons, and I know that the angle is 30 degrees, and I want to find what is the y component and what is the x component. I'm going to use SOHCAHTOA. So let's find the y component first. I know that I'm given the hypotenuse, that's the force, and the y component, if here's the angle, this is the opposite side, so opposite and hypotenuse together give me sine. So I know that the sine of 30 equals the y component divided by the total, and then if I multiply 50 to both sides, I get 50 multiplied by the sine of 30 equals the y component. On my calculator, I see that 50 times the sine of 30 gives me 25. That would be 25 newtons. Now I follow the same process if I want to find the x component. I'm given the hypotenuse, and here I want to find the adjacent side. If this is the angle, then x, the x component of that force, is my adjacent side. Adjacent and hypotenuse use cosine. So the cosine of 30 equals the x component divided by the hypotenuse. So 50 times the cosine of 30 equals the x component. And if I do 50 times the cosine of 30, that gives me 43.3 newtons is the x component. So that is a quick refresher on adding vectors and finding components. Don't forget to be the leaders that your community needs and deserves. Choose to be great and make your dreams come true.